Back at it again with another problem. We have recursive circus. So a lot of flavor text here. But the idea is you're gonna be given these nodes, then their weights, and then this will be the nodes that they are gonna branch. These are the nodes they're gonna be branching to, and then this is the structure it'll provide. So as you can see, UGML branches off to GYXO, EBII, GPTL, and that's what we have here, GYXO, EBII, GPTL. So given all of this, the randomized structure, you will have to return the base of your recursive tree. This looks really complicated, right? But all it really comes down to is parsing. And why is that? So if you organize your data well enough, you'll notice a pattern that if you get every single one of these branches, we won't ever find the bottom there. We won't ever find the base of the tree because it's never going to be branched off of, it's never going to be branched from. So you just have to get all of your nodes here on the left, and then you find which one never appears on the nodes on the right, and that's the problem. So let's go to Python so we can solve this. I'm gonna be doing Python for the first bit, and then maybe if I have time, I'll do Uiua. But so first, we'll open our files. So here we have test. Here we have the final input. So we open test.txt. Let's read, and then sf, and then we do f.readLines, and this should give us our input by a.y, and then we have that. And as you can see, all of these guys have a new line character at the end, so we'd like to get rid of that. So how that would go is we do a list comprehension. We do for row in f, for row we do a row dot strip that would remove the new lines. This is equal to xs, and then we do a print xs here. So we've gotten rid of the new lines. Now we want to separate them on spaces, so we get the tokens. So now we have PBGA 66, and then if we look at one of the if we look at one of the examples with the branches, we have PADX 45, and then it has arrow, and then the branches it has. Okay, looking good. So next up is, if we look at strip here, removes trailing white spaces. That's what we want. So next up is, for every row, we want to get rid of these commas. And the reason we want to get rid of these commas is if we no longer have commas here, we're only going to be left with alphabetical tokens and non-alphabetical tokens. And that would be really easy to filter out. So if we do for x in xs, so that would be for every array in our two-dimensional array, we'll do a compare here on the row. So for token in x, we'll do a tab here, and then we'll just say that we get token up until -1, and that would remove the last element if token -1 if the last element is a comma, and that would be it. So we do our current row, so it would be row equals, and this, oops, I'm not printing it. So if we print our rows here, I'll tab it out for symmetry, but if we print our rows here, it would be print row. You'll see that we have gotten rid of the commas here. Now it's just a matter of filtering out these two. And how that will go is we could do a normal filter using like filter. However, as you may notice, that all of these guys are only gonna be found on the second or the third, and you could just get rid of that. So if len row is equal to 2, that means that it's only going to be a node and its weight, then we just get rid of the second one, and in hindsight, we should prepare these nodes. In hindsight, we should be in hindsight, we should be preparing these nodes. Branches is equal to sets. And the reason we're going to be doing set is so that we get very efficient comparisons, and also it will remove duplicates. So if len row is equal to 2, then we actually don't need to check len row equal to 2. So if we can now do nodes dot add row 0, or the first element of our row, this will go to the nodes, and that's what we want. And then for the second part, for the branches, this is going to be a bit trickier, but the idea here is we want to remove the second and the third. So first, we'll check if the length of row is not equal to 2. That means that that means that it'll have these guys. And then if it's not equal to 2, then we can simply do a row, and then up until, I know we skipped the first 2, so I know the first 3, I should start from 3, and then up until the end. And then if we print these, we'll see that we'll get these guys: KTLJ, CNTJ, XHTH, PBGA, HAVC. Yeah, that's what we want. And we want to add all of these individually to branches. So we can do for token in row 3, we can do branches dot add token. We can connect these. It'll be a bit tidier. So now we have all of those. If we print our node and also our branches, we'll see that we have nodes here and we have branches on the bottom. And what I said earlier about finding which one doesn't appear on the second one is just a matter of set difference. If you remember your set theory, it would just be nodes dot difference of our, what's it called, branches. Then if we print this, we should get a set of the base, so pk and k. And to make it for completeness, we just unpack it. Ta-da! That is our base in fact. And if we change our input here to the actual test input, it's the file name, we should be getting UONJ. And if we look here, the answer is UONJ. So that's kind of cool. That was in Python, but we can do it much more terser in Uiua, of course. So if we do main.uiua, Uiua, can't spell, and that's actually not the file extension, it's Uiua. And then how that would go is, let's do it on test. So to read files in Uiua, you do FRAS, so it's file read as string. And then if we do FRAS test.txt, and then we print that immediately out, you'll see that if we do Uiua run, we got the same input as earlier, but it's gonna be delimited by this carriage return and then line feed. So we're gonna be splitting on that. So we just say this is our input. So, and then we do a partition on, we want to remove the carriage return line feeds. So if we do that, and then we do an over, basically duplicating the result of FRAS, and we do a membership, and then a not, and then finally a box. Oops, I'm not printing it. We should be getting boxes or pointers to rows of our array. So we see here, this is box TKNK41 UGML PAD XFWFT. So now a trick that not a lot of, well, not something that you can't really do idiomatically in Python is, instead of doing all of the filters earlier where we remove the comma and then we count if it's blah blah blah, and then we also do a split and a strip, we don't have to do that in Uiua because we just have to get every alphabetical character in our string, and we have to partition on that, and that would remove all of our numbers and arrows. So first of all, before we do that, let's do an array that we'll be getting off of. So if we have range 26, that would be range from 0 to 25, and then if we have at a plus 5, so if we add 5 to a, we get f. If we add 0 to a, we get a. So I hope you see what I'm getting here. But if we map at a addition to the array, we'll get the alphabet. So if we just have to check membership of every letter in our rows, of every character in our rows, and if they're in that, we're gonna partition on it. So let's do that here. Instead of boxing these guys, we'll do an operation on every row of them, and that would be getting the alphabet. So it should be A, and then range 26, then a plus here, and then we just do this like the same idea earlier, wherein we do an over, and then membership, and then we partition box. And if we do that, oops, we have something wrong here. Oh, of course, because we have to turn this into pointers too. So it doesn't error anymore. And if we print this out, this is truly amazing. Is we have these guys separated. We have PBGA, and XHTH, EBII, and then this is a row where we have branches, and this is a row where we have branches, and they're all really organized. And now it's just a matter of getting for the branches, or for the nodes, I mean, we just have to get row first of all of them. So if we do I and we print out n, we see that the first one of all of these arrays are gonna be our nodes. So it's pretty easy, right? So it's just 3 characters, and that took us like this amount to get row 0. And this is the same as row 0, getting rows and then the first of every element. Now we want to get the not first, we want to get everything but the first, and that would be drop 1, because if we have an array here, say range 5, range 0, 1, 2, 3, 4, and if we drop 1, we'll be getting rid of the first one. We will be getting rid of 0, and that's what we want. We just want to drop 1 on every single one of them. So for branches, we do let's print branch. So we just have to do a row drop 1, and there's gonna be a problem here because oh wait, I didn't even provide it. There's gonna be a problem here because it's gonna be confused with how it's going to drop, and that is because it's pointers right now and we have to unbox them. So we could do an unbox here, which is the referencing it, and then afterwards we do a box again, turn it back into a pointer. But an idiomatic way of doing this is we do a pack here, which infers where you have to box and unbox, and that does it for us. So these are gonna be the empty ones, and then these are gonna be the ones with the branches. So if we unbox all of these and then we join them together, again we can use pack here. We'll get all of our elements in one array, and for completeness we deduplicate them or remove the duplicates, and in this case there aren't any duplicates, but in the final test case there will be. And then once we have that, this is our set that we want to be set differencing on. So if we have n and b and we print these out, we just want to find the one that isn't in here. And how that would go is we just do membership, and then you'll see that one of them is going to be 0 because it's not a member of our second array. And then we just do a not to find that one, and then if we do where will give you the index of the ones in your boolean mask, so it will be 8 here, and then we can use that to select on our nodes list, and we get tk and k. And for completeness we do an unbox. We do a first and then unbox. k, and k. And then if we replace this with the actual test, should be 01707. It'll take a bit, but that's because of like the turning the entire file read into a string. But hey, we get the same answer. UON double J. UWN J. We get the same answer. UWN J. So thank you.